Okay, so we're going to use eigenvalues and eigenvectors to solve this problem. So I'm going to type it in and make a vector for, my matrix first. So there's my top row, middle row, 1, 0, 1. Bottom row, 1, 1, 0. Oops. Now, if you're paying attention, you could probably figure this one out ahead of time. Because when you do your determinants, you're probably going to get a nice, easy number here. But I'm going to go ahead and do the eigenvectors of it, eigenvalues rather. So the eigenvalues of this guy are as follows. Boom, there they are. So it's 0, 1, -1. Now, if you're doing this by hand, which of course, we've been doing it by hand, but I think I mentioned you can do it with this calculator, but let's go ahead and do this one by hand. It's not terrible. It's not great. It's not terrible. So 0 minus lambda, 0 minus lambda, 0 minus lambda. Right. And then 1, -1. And then 1, 0, 1, 1. And then 1, 1. Okay, so if you do the determinant, it's going to be negative lambda times negative lambda 1, 1, negative lambda, minus 1 times, and then it's 1, 1, 1, negative lambda. And then it's negative 1, and then 1, negative lambda, 1, 1. There we go. So let's do this out. So it's going to be lambda squared minus 1. It's going to be negative lambda cubed plus lambda. Yeah. And then it's going to be negative lambda minus 1. So plus lambda plus 1. And then it's going to be 1 plus lambda. So it's going to be minus 1 minus lambda. There we go. Cool. That's key. Hey, cat. That's key. So you get negative lambda plus 3. Is that what I said? Plus 3 lambda? No, this is a negative lambda, so this guy cancels, right? Yep, plus lambda. There we go. Cool. Equals 0. Factor a lambda out, and you get, well, factor a negative lambda out, you get lambda squared minus 1. That's 0, -1, and positive 1 for your solutions. Sweet? Sweet. Now, let's plug in our zeros and find our eigen vector. So you plug in 0 for theta, for lambda, you get 0, 1, -1. You get 1, 0, 1. You get 1, 1, 0. Oh, so this is one way to do it, of course, right? You can do it this way and guess, well, not really guess and check. It's going to be b minus c equals 0. That's a fact. A plus c is equal to 0. A plus b is equal to 0. Okay, what does that say to me? It says that, for instance, A is the opposite of C, and A is the opposite of B, and B is equal to C, which, I mean, duh, right? So what could you put in for those guys? Well, anything, but I probably would do 1, 1, 1. Now, you can't. Some people want, hey, Jay, I want to do 0, 0, 0. Well, you can't. It has to be matching. So there's that guy. Lambda equal 1. Let's try him now. If you put in 1, you're going to get -1. Now, this one I'm going to do a little differently. -1. -1. Now, this method here would work, but it's a pain in the butt. So let's do it using the null space business, okay? So the way to do this guy, of course, is, hey, let's find the null space. So to do that, what are we going to do here? Okay, and of course, the first thing you want to do is you want to make it equal. You want to you want to augment it with 0, 0, 0. Okay, now let's get rid of some stuff. So if you do a little R1 plus R2, R1 plus R3, you get, top one doesn't change, 1, negative 1, 0. Middle row becomes 0, 0, 0. That's hot. And then the bottom row becomes 0, 2, negative 2. You with me? Okay, well, that's cute. Now what can I do? Well, now I can divide these guys by, make these guys 1s, yes? Like that. And then now, let's say I want a 0 here, right? So I could just do what? R1 minus R3. And if I did that, negative 1. And then 1 minus 1 is 0. Negative 1 minus a minus. Oh, that's nice. 0, nice. That's cute. 0, 0, 0, 0. 0, 1, negative 1, 0. Oh, that's cute. What does that tell us? Well, it says that negative a equals 0, which means a is 0, obviously. And then b equals c. So in that case, I would do 0, 1, 1. So 0, 1, 1. And then for lambda equal negative 1, these would be positives, like so. But I would do the same exact scenario. I would just obviously do it a little differently because, you know, positives now. And with same principle. Okay, so if it were me, what I would do is I would go, let's do R1 minus R2 and R1 minus R3. So 1, 1, negative 1, 0. 1 minus 1 is 0. 1 minus 1 is 0. Negative 1 minus 1, negative 2. And then 1 minus 1 is 0. 1 minus 1 is 0. And negative 2. Well, that's cute. What does that tell me? Okay, well, it kind of tells me that what? C is equal to 0. Well, if C is 0, that means this piece here goes away, right? That means A plus B is 0, which means A is negative B. And again, a normal person goes, hey, let's make it 1, negative 1, 0. Guy wants to, of course, it's 1, negative 1, 1, 0. Anyway, hope that helps. Oh, wait, we're not done yet. Sorry. We did the hard part. We just didn't finish the solution, right? Sorry. So X, Y, and Z are a matrix, or a generic formula like this. So you're going to have C1 times 1, 1, 1, e to the 0t, plus C2, 0, 1, 1, e to the t, plus C3 rather, 1, negative 1, 0, e to the negative t. And then you're like, I don't like that. Well, I don't either necessarily. So that means it's going to be C1 e to the 0t, which of course is just C1, but I'm going to write like that right now anyway. Plus, this cancels out. See that? So nothing in the middle. And then plus C3 e to the negative t. Once I got that written down, I'm going to lose the e to the 0t because it just looks stupid. So y is going to be C1, again, just C1. The middle one's going to be C2, e to the t. And then this is going to be minus 1, so minus C3, e to the minus t. And z equals C1 plus C2t, e to the t rather. And then, of course, there's not one in the last one. Yeah? Nice. All right, that's the gist of it. That's your general solution. Now I hope it helps.